Hello everyone, welcome to Elite Engineer. In this video, we are going to see how we can simulate the Zeta Converter by implementing the maximum power point tracking technique, that is a Perturb and Observe maximum power point tracking technique. So in the previous videos, you have not seen that we have already explained you how you can implement Perturb and Observe MPPT technique to the buck converter, to the boost converter and to the SEPIC converter. Why I am going towards the SEPIC and Zeta converters, which is I think not being used by most of the YouTubers or most of the research papers, because it has some of the advantages that is lacking in some of the research articles that is being published in the literature. And that thing you can explore by comparing the results of different Perturb and Observe, Zeta converter and the modified maximum power point tracking technique that we will discuss in the literature in the upcoming videos. So this video is similar to that, and just there is a replacement of Zeta converter, right? So what happened here is I've just taken my solar PV panel and I've just put the input of 1000 watts at 25 degrees Celsius as my temperature. Now if I open this, you can clearly see that I have a 301.928 watts of power. Actually, this is a user defined panel that I want my panel to generate. If you want your panel should generate some X amount of power, you can adjust your open circuit voltage and short circuit current. And similarly, the maximum power point voltage and current should also be changed accordingly. Now, if I just see it, it will give the similar results like I have already shown you in the previous videos of mine, buck converter, boost converter and that of the SEPIC converter. So if I just see here, at 25 degrees Celsius, it's giving around 301.928 of power, and the current it's giving around, which I have mentioned here. Exactly same configuration, this solar PV array is there. Right, now the main aim is to just put the input of Zeta converter to the output of solar PV panel. Now I will just show you some of the in upcoming videos, like how we can just use our battery to with bidirectional converter so that it can charge and discharge. Now just if I open the Zeta converter, you can clearly see that the Zeta converter configuration, we already know that in Zeta we have some extra components of inductor and capacitor, which makes it little bit unfeasible, we can call. So to make this a feasible configuration, why we are using this, you can find the solution in literature. Actually, yeah, I'll just tell you, I'll just guide you with the paper. You can just read it. I'll get information why we are using these converters, right? Even though we have extra inductor and capacitor. So what happened here is, now my main aim of this video is to implement Perturb and Observe for operating this switch so that it can track maximum power from the solar PV panel, which is connected to the input side of this converter, right? Now this input of this is input of my Zeta converter, and we can call it the output of solar PV converter. Now here I have one input capacitor, here I have one inductor, again one inductor, and there's one capacitor, there's a diode, and there's again a capacitor, there's an output capacitor. These all the calculations you can easily find out from the book, and the reference for the book I'll just give in the description below. That will be redirected to the website, and here I'll mention some of the books and the simulation file also. You can easily find that in my description below. This is just to explain how my maximum power point tracking technique, that is a Perturb and Observe, is working in this condition. Now I've taken the output voltage and output current that is being fed to the resistive load. Like here I consider resistive load of 7 ohms, right? And now what I'm doing here is I'm just taking my voltage, that is input voltage and input current of Zeta converter, or we can call it a output voltage and output current of solar PV array. Now that is being fed to the Perturb and Observe maximum power point tracking technique. Now here this is a very simple code I have written, that is a D initial is 0.5, D max is 0.9, D minimum is 0.2, delta D is 0.01. I already told you that when we talk about delta D, it's like if we have some okay, I'll just show you. Now when my MPPT is working, it will generate the duty cycle. That duty will be fed to duty to pulse generator, that is a PWM pulse generator. And that pulse from here, I'm really sorry, I've just given name as PV boost pulse because the same configuration is being used and the converter is being changed here. So the PV boost pulse, it will fed to here, the switch of my Zeta converter. Yeah, fine. Now what happened here is, after the pulse is being fed here, it will make the solar PV panel to run on maximum power point tracking technique. Perturb and Observe is a very simple basic maximum power point tracking technique. So I'll just run this simulation and we'll come to know that how it is tracking to maximum power point tracking technique. I'll just add some of the research papers if you want to read, if you want to go through the Perturb and Observe maximum power point tracking technique, and there's various methods available in literature. Okay, I'll just see how it is tracking maximum power point. I just love to see that how it is tracking with triples, right? So see, it's our transients, and here it comes our steady state. Now you can see that triples, it is repeating continuously, and now we are getting the power of 300 watts here. See, this also we are getting the same like duty, and this also we are getting same like our, this is our actually voltage, this is our current, this is our power, and this is our duty, which is being generated like a triples. Okay, yeah, that's all. So if you want the simulation file, you can just download by checking the link given in the description, and that will redirect you to the website, that is a Light Engineer website where you can download the simulation file. And if you want the more of videos, you can just comment, so that I will provide you more of such content. Thank you for watching this video. Hope to see you in the next video.